In this video, we're going to learn about the nomenclature of ethers. This will add additional suffixes to your vocabulary. We'll start off with a brief overview of ether nomenclature in the common lingo slang. In the common language, which I hope eventually dies, but I find myself naming things this way too. When you view an ether in this common nomenclature, you kind of view it as the O with things bonded on either side of it. So you have the O equals ether. And then we have an ethyl and a methyl group hanging off of the O. So it's like the O is the center of the universe. And so you alphabetize these things. And so that's ethyl, methyl, ether. If you had two methyls, it would be dimethyl ether, or diethyl ether if you had two ethyl groups. Now, this works fine for simple ethers, but once you start adding like branches and stuff, then this becomes really ugly. So IUPAC stepped in and said, okay, let's not view our ether in that way. Let's instead pretend that we have a long chain. So our longest chain here was 2 carbon long, so 2 carbon long. And then we view this shorter chain as a substituent on the bigger chain. So now we turn that molecule sideways. This is our parent chain, and that's a substituent on the parent chain. Ethers are so low down on the food chain that they won't change your suffix at all. And so this is ethane, and this is a substituent on it. This has a 1 carbon and an oxygen, so that is methoxy. Oxy meaning one oxygen, and that meaning 1 carbon. So 1 carbon, oxygen, methoxy. And so this is methoxyethane. We don't need a 1 because if we put this methoxy group on either carbon, it would be a number 1. So there's no isomers possible. So that's how we would translate this name into IUPAC. Here's another example. In this molecule, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. And so that is octane. But we can minimize numbering by numbering from the other direction. You can see that I called this carbon number 5, but the lowest possible number is a 4. So we want to number from the other direction to minimize that numbering. This has 2 carbons, and so that is ethoxy. And so we have, that's off number 4, so that's 4-ethoxy octane. So you just kind of have to picture it that this is a substituent on the longer chain. Kind of change the way you're viewing it. Alright, here's a practice problem for you. Go ahead and draw the condensed structural formula and name this compound. When you're ready to check your work, unpause the video and let me know how things go. Okay. Alright, let's go over this. So this one does say condensed structural formula, so let's make sure that we are doing the correct structural drawing type. This means that we are going to want to leave some space to fill in our hydrogens. We got 4 carbons long, so that's 4 carbons. We have a methoxy group off of the second one. So that means off the second one, I have an oxygen and the methyl. Now I can go back and fill in my hydrogens. The terminal ones are going to need 3 carbons. This one will need 2 carbons, and this one will only need 1. Hydrogens. Those are hydrogens. Was I saying carbon? I was not meaning carbon. I was thinking hydrogens. I don't know what I was saying. Okay. Forgive me. Alright. Let's go about this one. This one has 1, 2, 3, 4, 5. The longest chain is 5 carbons long. And so that is pentane. This is a substituent on this longer chain. That is 1 carbon and an oxygen. And so that is methoxypentane. That methoxy could have been off of other carbon numbers though, so I am going to put a 1 to indicate that it's off of the first one. And underneath the drawing was not the condensed structural formula. I need to update the figure.